Welcome to Hyperphysics. In this tutorial, I'm going to discuss a different aspect of quantum harmonic oscillator, that is the frequency dependent probability. So let's get started. In order to understand the frequency dependent probability in quantum harmonic oscillator, I've given a question here. I'll solve this question in two ways. One is very straightforward method and one is through a very shortcut method also. I'll discuss both of these methods. So stay tuned for the shortcut method at the end of this video. So let's get started. So the question is like this. A quantum particle is the ground state of a one-dimensional harmonic oscillator given by the Hamiltonian, and at a given time the frequency omega naught changes abruptly and the Hamiltonian becomes like this. So we need to find the probability that the particle is in the ground state of the new harmonic oscillator. So it's given like this: the initial state of the system psi naught of x to be like this, where y is h bar divided by m omega naught. So here in the question, the frequency is changing abruptly, so that will move to a new state. I'm going to write the state of that system to be psi naught of mu. So new wave function will be scaled by like this, square root of pi. I'm going to write it by n because y depends on the frequency. As omega changes to eta omega, the y will changes to yn exponential of minus x square divided by 2yn squared. Okay, so how to find the probability is the next question. So for this question, it's given that the frequency changes abruptly. This is one concept in quantum mechanics known as the adiabatic approximation, which is a very vast theory to be precise. But the concept is to solve this problem is you understand in such a way that the system is changing abruptly. That means the system has not completely changed from in the initial state to the final state. Okay, so the system has some contribution of the initial state even though the frequency has changed. So there is some part of the initial state that is still in the final state. So to understand or get the probability for these kind of questions, what we do is we find something called as the overlap integral, that is I, that is minus infinity to infinity within the integral psi star, that is for the new, into psi of x dx. This is something known as the overlap integral. What this means is that there is a contribution of initial state. This is the initial state and this is the final state. We need to estimate how much contribution is there in the final state contributed by the initial state. So to find this integral and squaring this integral will give you the probability. The probability will be modulus squared of the overlap integral. So this is the idea to solve this problem. So I'm going to solve this problem, the whole thing, in a straightforward way. So first I'm going to write the overlap integral like this. I is equal to minus infinity to plus infinity 1 over, I'm going to multiply these normalization constants together. I'll get square root of pi yn exponential of minus x square by 2y square times exponential of minus x square by 2yn square, okay, into dx. Dx is there, dx. Okay, I'm going to solve this integral. I equal to 1 over square root of pi yn, because it's a constant, I'm taking it outside, minus infinity to infinity e to the power minus x square times 1 by 2 in the brackets. I'm going to write 1 by y square plus 1 by yn square dx. Okay, so I'm going to make a substitution here. I'm going to assume 1 by ya square to be equal to 1 by 2 times 1 by y square plus 1 by yn square. Okay, so that will make our integral very simple. It will reduce to this form: 1 over square root of pi by yn minus infinity to infinity e to the power minus x square by ya square dx, right? And we know this integral as a very famous integral, as a quotient integral, is e to the power minus ax square dx will be square root of pi by a. So here if you compare that, you have a as 1 over y a square, so this integral will reduce to 1 by square root of pi yn into pi root pi times ya. Okay, so the overlap integral we have calculated in terms of ya and yn to be ya divided by yn in the square root. Okay, so now we need to write ya in terms of the frequency or the eta and everything. I'm going to rewrite what is y square. Y square is h bar divided by m omega naught, and yn is h bar divided by m eta omega naught, y omega square. Okay, and also 1 by ya square is 1 by 2 times 1 by ya y square plus 1 over yn square, right? So we have the overlap integral like this. I'm going to rewrite in terms of omega, h naught, eta and everything. So we have, first we'll do with the yn to be equal to y is square root of h bar by m omega naught, and yn is square root of h bar by m eta omega naught, and yn, that is yn will be h bar divided by m omega naught, and in the brackets you have 1 over square root of n, right? That is yn. So we have square root of this thing that I'm going to write like this: square root of yn is square root of h cross divided by m omega naught into 1 over eta whole raised to 1 by 4, the square root of this thing, right? So we have calculated square root of yn. Now we need to calculate what is ya. Okay, I'm going to put that in the square brackets here. So we have ya square to be 1 by 2 into 1 by y square plus 1 by yn square. So what we have, we can solve that thing like this: 1 over 2, and y square is h cross by m omega naught, so this will be m omega naught by h cross plus, this is yn square, this will be m eta omega naught divided by h cross, which implies 1 by ya square will be m omega naught by 2h cross into 1 plus eta, right? So we have ya square, that is equal to 2h cross by m omega naught into 1 by 1 plus eta, and ya to be equal to square root of 2 and the square root of h cut by m omega naught into 1 by square root of 1 plus eta. So we have found this y square root of yn and phi a to be like this. And now we will evaluate the overlap integral I, that is equal to ya divided by square root of yn, that is we have what is 1. This is 1, ya is 1 over square root of 1 plus eta and times root 2 into square root of h cross by m omega naught into, and what is square root of yn, that will be, yeah, that will be divided by square root of h cut by m omega naught into root eta raised to 1 by 2, right? So I'm going to rewrite, cancel the similar terms here, and we are left with the overlap integral to be square root of 2 eta raised to 1 by 4 divided by square root of 1 plus eta. So we have found the overlap integral. So now we can find the probability, which is p is modulus of modulus square of the overlap integral, that is 2 square root of eta divided by 1 plus eta, right? Or you can rewrite this thing in a different way, in such a way that it's there in the options. It's 2 divided by square root of eta plus 1 over square root of eta. So this is how you find the probability for a system where the system changes abruptly. So the option will be option C is the correct answer if you're doing by the straightforward normal way, because most of the times sometimes this can be asked as a numerical questions also. That's why I did like this. So now let's go to the shortcut method. The shortcut method is very easy if you look at the options here, and if you think like this, okay, what happens when eta is eta tending to omega, or eta tends to 1, or omega prime will tend to omega. Okay, just think about this limiting case. So if you think about that case, you can see that the overlap integral will be the old overlap integral, and old overlap integral will become the same as the initial state, right? So the new one and the old one will be the same. So in that case, you have the overlap integral minus infinity to infinity psi 0 of x and psi 0 of x dx, that will be equal to 1. So square of that will be also 1. So probability has to be equal to 1. So if you check for eta equal to 1, just put eta equal to 1 and check the options. You can see in the first option it will be 1 by 1 plus 2, that will be, this is 1 by 3, which is not the probability that we need. And for this one is 2 divided by 1 plus 2, that is 2 by 3, which is not the probability that we need. And here you can see that's 2 divided by 1 plus 1, that is 2 by 2, that is 1, the probability, that's the correct answer. And this will be 4 divided by 1 plus 1, that is 2, which is not the probability that we need. So this, by changing this eta to tending to 1, we can easily find the probability by looking at the options. Okay, so I hope you like this video. So please share if you like this video to your friends. It will be helpful for CSIR and other competitive examinations like TIFR also. So I hope you like this video. Please subscribe to my channel and please like and comment. If you have any doubts, please put in the comment section. So thank you everyone.